Here's problem 1329. Planet 0 has a mass of 4 times 10 to the 23 kilograms and a radius of 2 times 10 to the 6 meters. A 10 kilogram space probe is launched vertically from the surface of 0 with initial kinetic energy of 8 times 10 to the 7 joules. What maximum distance from the center of 0 is achieved by the probe? So here's Planet 0, and we're going to launch a space probe from its surface, and hence it's going to start at the radius of the planet, away from the planet, and maybe achieve some maximum distance, which we'll call little r, eventually. Not in a stable orbit, it's just achieving that distance. So what we have is that our initial energy should equal our final energy. In other words, our initial kinetic energy plus our initial potential energy should equal our final kinetic energy plus our final gravitational potential energy. But if we just make it out to that final position, then we're going to have no movement left. We're going to have no final kinetic energy. So what we have is our initial kinetic energy, which we're told is 8 times 10 to the 7 joules, plus our initial gravitational potential energy, negative g, mass of the planet, mass of the satellite, over our initial radius, which is the radius of the planet. That should equal our final potential energy, which is negative g, mass of the planet, mass of the satellite, over our final radius from the planet, which is r. Let's divide both sides by gmm and multiply by -1, and so we have 1 over our final distance r is equal to a negative 8 times 10 to the 7 divided by gmm, plus gmm's cancel out, so that's just 1 over radius of the planet, like that. Sounds good. Take 1 over both sides of this, so our final radius is going to equal 1 over all of this stuff, which is going to be 1 over the radius of the planet minus 8 times 10 to the 7 divided by gmm. So r is going to equal 1 over all that stuff, which is 1 over the radius of the planet, which is 2 times 10 to the 6, minus 8 times 10 to the 7, divided by gmm, which is going to be 6.67 times 10 to the minus 11, mass of the planet, 4 times 10 to the 23, and mass of the satellite, 10. So this is equal to 1 over, and 1 over 2 times 10 to the 6 is actually 5 times 10 to the minus 7, minus, and all this other stuff, 8 times 10 to the 7 over all those three things, actually comes out to 3 times 10 to the minus 7. So this is going to be 1 over 2 times 10 to the minus 7, which is 1/2 times 10 to the 7, which is going to be 5 times 10 to the 6 meters. So the final distance, maximum distance from 0 is achieved when we have no final velocity, and that's going to be at a distance of 5 times 10 to the 6 meters from the center of 0.